Physics 2211, Lab 2. So, introduction of the lab. The purpose of this lab is to observe the motion of a falling object and compare it to two computational models. So the first model only takes into account the gravitational force, and the second one accounts for both air resistance and gravitational force. And as we can see later, it has very little effect as I used a heavy golf ball and had a small delta T. The model with drag will be the closest to my actual tracker data. So here are some fundamental principles that I use. So I use Newton's second law, which is force equals dp dt, gravitational force, which is force of gravity equals mg, and drag force, which is force of drag equals negative bv squared v hat. So here are some equations I use that I put into my code script. So position update formula, which is R final equals R initial plus V delta T. And then the velocity update formula, which is V final equals V initial F net for M times delta T. So here are some initial conditions. So my system is the golf ball. The surrounding is gravity in the air. It's my initial position. This is my initial velocity. Um, and then the mass of the object, and then the time. And the reason why the velocity is negative is because in the x direction is because I flipped the video. Here's my tracker data. Of course, like I said, the x is going has a negative slope, which means I flipped the video. But as you can see, the y value means it goes up and then it goes down. So here's my data without drag, so gravity only, and this is it with drag. So the results is the computational model and the experimental model are somewhat similar. Air Force made a little difference due to the large weight and the short time in the air, and then some sources of error could be like human error when tracking the object, and we could have applied a non-constant force to the ball. So here are some observations. So terminal velocity happens when the force of drag pointing up balances out the force of gravity pointing down. This lets us know the net force on an object. The model using air resistance predicts a terminal velocity, and my object did not reach terminal velocity due to its path. So what if the terminal velocity would be the same regardless if the object was from rest or thrown with initial force? Initial velocity does not play a role, only weight does, and throwing an object with initial force would cause it to slow down until it reached the same terminal velocity as the model with no initial velocity. And as you can see here, um, my my graphs with drag and with only gravity are almost the exact same, but the data points I put in are slightly different, but they're by a small margin. So air resistance here did not play a huge factor in my data. All right, thank you.